So the new section is 6.2. We're kind of continuing our foray into Chapter 6. This one's exploring and estimating rates. So exploring and estimating rates. These are real similar to what we did in 6.1 with the ratios. That a ratio we had, I wouldn't write this stuff here in green, I'm somewhat giving you a chance to catch up, but if we had like a ratio of like 1 to 3, you could write it that way as a ratio. You could say a 1:3, or you could say a 1/3. Yes? A rate is basically going to be the same sort of thing. It's going to be a ratio. The difference is in the units. Where when we had like 1 to 3, if you had like a 1 to 3 guy to girl ratio, it's really just like a person to a person. The units are the same. The difference is going to be when you have a rate. So a rate, the units have to be different. So a rate is going to be a ratio where the two numbers have different units. So ratio where the two numbers have different units. But really, you can kind of treat it exactly like we did with the ratio. Just now we'll have different units in the things. So, for example, came up with this. So, back when I was younger, my brother had a sailboat, and we'd pull it down to Key Largo once in a while, like spring break or after college was done, or once for a long weekend, which was kind of nuts. But anywho, so if you're looking at like driving there, I put it into Google Maps. It's 1,541 miles from Grand Rapids to Key Largo, and we did that in 28 hours. And I'd encourage you just to do the H for the hours instead of the HR, but somewhat up to you. Later on in life, high school, you'll just do the H. This is going to be a rate. It's kind of like a ratio, but the units are different. In the numerator we have miles, in the denominator we have hours. What I wanted to do is then lead us up into the next thing, which they call a unit rate. So a unit rate is going to be that same sort of thing, but now what we want to do is we want to get it so it's a number over 1, or really just as a single number instead of as a fraction. So I'm going to say you divide to get a number over 1. So if I were to punch in the 1,541 divided by 28 in a calculator or do the long division, for that I should come up with a tiny bit of rounding, 55 miles. I wouldn't necessarily write it this way, but it's 55 miles over 1 hour. Or normally people just write 55 and then miles over hours, miles per hour. So in other words, as we were going down there, our average speed would have been 55 miles per hour. The advantage of the unit rate is it's going to make it easier to go through and now solve stuff with that. Say, well, how far did you go in 4 hours? You know, it's like you drove 4 hours until supper time. How far away from Grand Rapids were you when you had supper? It's easier to go through and use either that or this unit rate as opposed to the original one, the 1,541 divided by 28. All right, then the very last section, the book tries giving you some questions where they say, which one's a better deal? So I'm going to say, example, which is a better deal? And I kind of made up numbers here, so I have no idea. I'm not a golfer, but I'm going to say 12 golf balls for $15, or 18 golf balls for $27. So if you're like me and you'd rather pay a little bit more money and get a better deal, I'm a sucker for a good deal. You want to figure out, well, which one's is it better to get the 18 golf balls? Is that actually cheaper per ball? Usually it is. Often it is. They package it that way. So now, when we look at the numbers, really what we have to do is we have to say, well, this 12 divided by 15. Do we want to do 12 over 15 or do we want to do 15 over 12? And you really could do it either way as long as you kind of know what you're doing. Because in one way, it's going to be you want the smaller numbers, the better deal. And the other way, you want the bigger numbers, the better deal. So do you want to do balls per dollar or dollars per ball? What are you thinking? Okay, so if we're going to do dollars per ball, so I'm going to kind of work here on this side. I'm going to do the dollars divided by the number of balls. And when I do that, well, so then I take for my first one, I have to do the 15 because that's the number of dollars divided by 12, that's the number of balls. So my first one is going to be 15 divided by 12. So if you were to punch that in, you come up with $1.25. So the 125, that's going to be the cost per ball. Fair enough? Well, if we do that with the second one, so I need to do 27 divided by 18. Because if the first one is dollars per ball, the second one needs to be dollars per ball. And now if I punch that in, I get 1.5. So the second one now I'm paying $1.50 for each ball. So the better of the two is going to be to get the 12 or the 18? 12. That the 12 is going to be the better deal because you're only paying $1.25 for each golf ball. You could take and do the same exact problem a different way. That you could, if you wanted to, say balls per dollar. And this time, do we want the better deal? Is it going to be a bigger number or a smaller number? Bigger. So you kind of have to look at how you're combining them together. If you're going with what we did before and you're doing, all right, how many dollars per ball, the better deal is going to be the smaller number. Where if instead you were to divide the numbers the other way and say, all right, my first one here is going to be 12 divided by 15. That's 12 balls for $15. And my second one was 18 golf balls divided by 27. Now as I go through and punch the math in for those, so 12 divided by 15 gives me 0.8. So I get 80% of a golf ball for $1. Then if I do the 18 divided by 27, I get 0.67, so 2/3 of a golf ball. Now it's going to be the bigger number that's the better deal. That it's still that same 12 golf balls for $15, but here you're looking for, well, I can get more of a ball for $1 rather than the other. Does that kind of make sense? So you can figure out the problem either way, but for me the way we did in green makes more sense. What's the cost per ball? But it's just important to know which way you're combining the numbers, combine them the same way in both scenarios, and then pick either the higher number or the lower number, whichever is best.